One last pressure transducer we're going to talk about. That's the fuel tank pressure sensor. It is a pressure sensor that changes fuel tank pressure into a voltage signal that can be used by the EVAP system. We have the standard things we expect to find. First, the green arrow is pointing to the 5 volts saying, do you have 5 volts? Yes. Do you have a good ground? Yes. Then you can evaluate the sensor signal. We have a specification for this Ford. It says we have about 2.5 to 2.7 volts with no vacuum or pressure in the tank. We do it engine off because it's a good place to find no pressure. Let's take a look at what it's going to do. This is a graph showing seconds across the bottom, voltage in the far left in black, and inches of water, H2O, in red. The idea all EVAP systems are going to use is they're going to pull a weak vacuum. And a weak vacuum is defined about 7 inches of water is a typical weak vacuum. That equates to about 1 psi. It's a very small amount of vacuum. What we do is we close up the vent where the arrow is right now. And we want to make sure we don't start building pressure. Because if we started building pressure there, we would have a situation where we have too much evaporation of the fuel. The other thing we don't want to see is we don't want to see the vacuum drop too far too fast because we haven't opened the vent yet. Right at that line, where that line crosses, we close the vent and we start duty cycling a vapor management valve on Ford, purge solenoid on other manufacturers. And we're going to go over and try to pull this vacuum down to about 7 inches, which is here. If we can't get to this point, we have a major leak and the test is over. That's true of all manufacturers. If you can't pull a weak vacuum, you fail EVAP right away. It's a gross leak. We're going to close the vapor management valve, purge solenoid, whatever the case may be, with the vent closed and seal the system up and see if we can hold a vacuum. This is called vacuum decay. If the voltage rises too fast, that means we're losing a vacuum. We have a leak. The speed of the leak will determine whether it's a 40 thousandths or 20 thousandths leak. Now, not all manufacturers do it the same way. Toyota GM, we're picking 2. But remember, all manufacturers, import and domestic, are going to use the same procedures. Their numbers will vary. We start off with the same thing. Our 5 volts we expect to see. Our ground. Then at pin B, we look for the voltage. We're looking at 140 to 160. Now let's look at the chart for EVAP. Start off low. We close the vent valve. We make sure it doesn't drop down too far. This checks for opening of the purge solenoid or leaking purge solenoid. Then we start the purge solenoid duty cycle to pull it up to get a weak vacuum. If we can reach that weak vacuum at the first dash line, we stop and hold it. And the question gets to be, can we hold a weak vacuum at this point? If we can hold a weak vacuum, we pass the leak test. It depends on how quickly we drop between the first reading and the second reading will determine how big the leak is. Small leaks go further out. Larger leaks are close in. And gross leaks won't pass the first test. We build a vacuum. So these are specialized things. And they're used by all manufacturers. Even if we have the newest thing with natural vacuum leak detection, they use these same sensors. So you're going to have to be working on these. All you need is specifications for whatever manufacturer you're working with. Now, there's some additional stuff in the manual you might want to reference, but this concludes all of the interactive training at this point.